Hello everyone and welcome to Iland Technologies presentation on the latest advances in quality of service, that's QoS, in Draitec routers. Now we did run a webinar some time ago where we looked at the quality of service features available in Draitec routers. Since then there's been some improvements and I'll go through those today. My name's Darren and I'm the Queensland sales rep at Draitec Australia and New Zealand. So first up we'll look at what quality of service is and why we need it. Next, we'll look at QoS implementation in Draitec routers and how hardware acceleration is used for it. Then we'll take a look at the configuration options available and go over a QoS configuration example. Finally, we'll look at how Vigor ACS3 can be used to improve VoIP quality by using SD-WAN. Let's start by looking at what quality of service is. Here we have a definition of QoS which says that quality of service is the ability to provide priority to different applications, users or data flows, or to guarantee a certain level of performance to a data flow. In a nutshell, it allows us to prioritize some traffic over others. Okay, so why do we need it? When it comes to internet usage on a network, some applications or data flows cannot be delayed or interrupted, or in a busy network, one application may be more important than others. For example, VoIP traffic cannot be interrupted since it occurs in real time, and it will be difficult to carry out a conversation if the voice transmission keeps dropping out. Another example may be that access to the finance system may be more important than browsing Facebook or surfing the internet. Data flow is influenced by several factors. The first is reliability. A lack of reliability usually means that data packets can be lost. For TCP/IP communications, it will result in slower transmissions since the packets have to be retransmitted. But for UDP packets, which is used for VoIP communication, it will result in dropouts which will cause broken audio. Next, a delay in data flow will be noticeable for real-time applications such as VoIP. This is often referred to as lag and is really annoying if you've ever experienced it on a phone call because the two parties usually end up both trying to speak at once. This happens because the responses are taking longer to arrive compared to a normal conversation. It also makes online games frustrating to play. Jitter. Jitter is a variation in packets belonging to the same data flow. It happens when some packets take longer to travel from one system to the other, which can lead to crackly audio or a degradation in video quality amongst other things. And available bandwidth. Some applications need more bandwidth than others. For example, a video stream will require much higher bandwidth than a web page. Insufficient bandwidth for a video stream usually results in buffering and stop-start behavior. So in IP networks, QoS is used to prioritize critical traffic over non-critical traffic. For example, you may want VoIP traffic to have a higher priority than email or HTTP traffic. Also keep in mind that the internet is a best effort service and there's no guarantee that packets will not be dropped due to congestion or be unduly delayed. Real-time applications such as VoIP and video over IP will work okay when there's sufficient bandwidth available, even without QoS enabled, but during peak hours, network congestion will result in increased packet loss and delay, resulting in degraded services. Okay, so let's take a look at QoS implementation in Draitec routers. In Draitec routers, there are two components used in the primary configuration of quality of service. These are classification, which is used to identify low latency or crucial applications and mark them for high priority service level enforcement throughout the network. The other component is scheduling, which is based on the classification of the service level, so it can assign packets to queues and associated service types. The primary configuration of QoS is effective under heavy traffic load conditions. For example, if the WAN connection becomes congested, then data requiring priority has to compete with other data. Draitec QoS will dynamically allocate the required bandwidth for high priority data. I'll go over the configuration options for this later. Also, QoS should not be confused with bandwidth rate limiting. This has the effect of slowing down some PCs, but it doesn't prioritize data traffic as such. For large-scale network implementation of QoS, the usual method is to use DSCP, that's Differentiated Service Code Point, and IP precedence at layer 3. With DSCP, you can create 64 classes, and it's backwards compatible with the legacy system, which uses the type of service, that's TOS field, in the IP header to define 8 service classes. Differentiated services, or DiffServ, provides a method to classify and manage network traffic to provide quality of service in IP networks. For packet classification purposes, in the IP header, diffserv uses a 6-bit differentiated services code point, DSCP, in the 8-bit differentiated services field, the DS field. The last 2 bits are currently unused. This diagram shows a QoS-enabled network or differentiated service, diffserv or DS framework. Here, each network provider has a service level agreement to guarantee the end-to-end network service level. So the appropriate QoS settings have to be enabled across the whole network to give priority to a particular type of network traffic such as VoIP. Each DS domain will prioritise this traffic. This is called per hop behaviour or PHB. An example of this is how Telstra prioritises VoIP traffic over the NBN. They use DSCP46 to tag VoIP traffic across their network. For VoIP class traffic, it only recognises DSCP markings 40 to 47, that's decimal, and will drop unrecognised packets. Per hop behaviour is a term used in differentiated services, diffserv. It defines the policy and priority applied to a packet when traversing a hop, such as a router, in a diffserv network. Here we have some examples of DSCP bit settings. All zeros is used for best effort. The definition of PHB includes expedited forwarding, EF, assured forwarding, AF, and best effort, BE. In the table shown here, you can see that assured forwarding defines the 4 classes of delivery or forwarding classes and 3 levels of drop precedence in each class. These are low drop, medium drop, and high drop. The combination of classes and drop precedence gives us 12 separate DSCP encodings from AF11 through to AF43. If congestion occurs within a class, the packets with the higher drop precedence are discarded first. Prior to diffserv, IPv4 networks could use the precedence field in the TOS byte of the IPv4 header to mark priority traffic. The first 3 bits are the precedent bits, which are mapped to a diffserv class. So we have CSO equals IP precedence 0, CS1 to IP precedence 1, and so on. If a packet is received from a non-diffserv aware router that uses IP precedence markings, the diffserv router can still understand the encoding as a class selector code point. Here we have a couple of DSCP values. DSCP46 is used for high priority traffic. It's often used by ISPs to handle VoIP traffic over the internet. At the other end, we have DSCP value 0, which is for best effort handling over the internet and can be used for low priority traffic. Dratek routers have 20 pre-configured diffserv code points that can be selected for the QoS setting. These include 7 IP precedence classes and 12 AF classes that were discussed previously. The EF class is at the bottom of the list. Okay, let's take a brief look at hardware acceleration and QoS. In the latest router models, such as the Viga 2765, 2766 and higher, Dratek have added hardware QoS to take advantage of the hardware acceleration features in these routers. It's available in firmware version 4.4.0 and above. When hardware QoS is enabled, it will have higher priority than software QoS. So in the QoS settings menu in the new firmware, you'll see hardware and software QoS setup separated into 2 sections with the hardware settings at the top. As noted on this menu page, hardware acceleration must be enabled in the router for hardware QoS to work. In future firmware releases, Dratek may have hardware acceleration enabled by default, so you'll be able to skip this step. One drawback when hardware acceleration is enabled for QoS is that even though the QoS performance is increased, the reserved bandwidth of each class will be fixed and is not released for the others class category when not fully utilised. If you do need to enable hardware acceleration, you'll need to go to the hardware acceleration and setup menu page in the router as shown here. Hardware acceleration was discussed in a previous webinar at the link shown here, so you can view it later to get a better understanding of this feature. You'll find that link in the description below as well. I'll now briefly go over the configuration options for QoS in Dratek routers. For DreOS routers such as the Viga 2865 shown here, the QoS settings are done in the Bandwidth Management Quality of Service configuration menu. You'll notice that there's 4 sections in this page. At the top we have the General Setup menu. Here we can configure QoS for each WAN interface. You'll notice that we have 4 categories for bandwidth allocation: Class 1, Class 2 and Class 3, as well as others. For each WAN interface, you can adjust the percentage of the bandwidth to reserve for each class. Just make sure that the total of all the values adds up to 100%. The default setting is 25% for each class. You should note that the bandwidth allocation is dynamic, so if the reserved bandwidth is not required for the specified applications, it will be used for other internet activity. Clicking on the WAN link as shown here will bring up the UDP bandwidth control. If you're running VoIP services, it's not recommended to enable this option, as it will seriously impact VoIP communication since it uses UDP. You'll also notice that you can also select the direction for QoS control. This can be in, out, or both. The next section in the quality of service configuration menu is the class rule. Clicking on Add will bring up a menu where you can enter the required details, including QoS class IP addresses to be included and the service type's diffserv code point. There are a number of pre-configured service types from the pull-down list that can be selected. If the service type required is not in the list, you can create your own by clicking on the user-defined option in the list. If you select User Defined, you'll see extra options to define the service name, protocol, and port number. This will then be saved as another service type in the pull-down list. There's also a pre-configured option to enable QoS for VoIP traffic. All you need to do here is just select the checkbox to enable it. There's no need to create a rule for one of the classes. Clicking on the green icon will display the VoIP QoS status for attached devices. An additional feature in the QoS settings is the option to tag outbound traffic as shown here. You can select the diffserv code point or precedence value from the pull-down menu. For QoS to work correctly, the router needs to know the actual bandwidth of the WAN connection. For ADSL and VDSL WAN connections, the router can work out the actual upload and download speeds, but for Ethernet WAN connections, the router may be connected to an external modem, which may provide much lower bandwidth than the capacity of the router WAN interface. So here we need to enter the actual upload and download speeds. You can determine the speed by running speed test or some other utility to check your internet speed. You can run the test a few times to get an average value and then take 80% of the average measured speed to be the value to enter into the router settings to maximize the QoS performance. In the VIGA 2865 and most other routers, we also have App QoS as shown here. Here we have a list of predefined applications, traceable and untraceable. We just need to select the required application and select the QoS class to apply to it. In the traceable category, we now have a much greater list of applications compared to earlier model routers. The categories are listed here and include instant message, VoIP, protocol, tunneling, stream, remote control, web HD, game, Google services, Amazon services, and eLife. Again, in the untraceable category, we also have a greater list of applications compared to earlier model routers. Untraceable apps are not easily traced by the VIGA router. The categories include some of the same categories in the traceable category, but the apps are different. There's also an option to add QoS in firewall rules. Here you can select the required QoS class for the firewall rule. Okay, let's check out a QoS configuration example. This example is based on one of the application notes in the Draytech knowledge base. In this one, we want to set up QoS to reserve bandwidth for a VPN connection, and we want to give priority for traffic going to the FTP server at 192.168.20.11, shown on the right, from the 192.168.10.1 subnet, shown on the left. The first step is to log into the VPN client router on the left and go to the Bandwidth Management Quality of Service Configuration menu. And that looks like this. Then we want to edit class 1 in the class rules. Next, we need to select Enable to activate this rule and click on Edit to enter the local IP subnet address 192.168.10.0. The next step will be to set up the QoS settings. We select direction, WAN speed, and bandwidth allocation for the rule that we configured. Also, we reserved 55% of the available bandwidth for Class 1. Once the configuration is complete and the VPN is running, we can click on the status option to look at the traffic details. What we should see is that traffic for the VPN class will appear as the green bar shown here, indicating the amount of traffic being prioritized. Another example where we use QoS settings is in WAN traffic shaping. Some service providers require users to enable WAN traffic shaping on their routers to limit outgoing traffic to match the data rate that they've purchased. For example, if the data plan is for a 50 megabits per second Ethernet service, then any outgoing traffic exceeding 50 megabits per second will be dropped by the service provider. As a result of the outgoing data packets being dropped, the user will notice that the actual data rates will be around 50/20 incoming and outgoing or similar. A solution for this is to use quality of service settings to limit the outgoing traffic. To take into account burst traffic, it's recommended to set the value for the outgoing traffic rate at less than the data plan rate. For example, for a 50/50 Ethernet service, set the outgoing limit to be 48 megabits per second as shown here. Viga ACS3 is the latest management platform for Draitec devices. It has the SD-WAN feature that will help to improve VoIP quality. This can be used in addition to the QoS settings in the router to prioritize VoIP over other data traffic. SD-WAN can be used with multi-WAN routers when 2 or more WAN connections are set up in load balance mode. For load balance weights, you can select quality-based mode, which checks transmission rate, latency time, and the jitter time. With SD-WAN, router WAN interfaces are constantly monitored, and MOS as well as active WAN quality is checked. MOS, or MOS, is an abbreviation for Mean Opinion Score and gives an indication of the WAN quality and reliability. The active WAN quality shows the current interface quality. On each interface of the CPE, that's customer premises equipment, data usage, latency, jitter, and packet loss are monitored and recorded. This information is then used to make adjustments to improve VoIP quality. Using this information, ACS3 will adjust the metric to make sure the Edge router always uses the best quality interface for VoIP to give the best VoIP quality. SD-WAN will monitor each live call and fail over to the secondary VoIP WAN if the primary WAN's MOS drops. In the diagram shown here, WAN 1 has the highest MOS of 4.3, so is selected for VoIP calls. In addition, every VoIP call and WAN interface used is logged with a MOS. This information can be sent to the network administrator if required to check performance. So to summarise, some points to take away from today's presentation are that quality of service is an essential feature to ensure that some applications or data flows are not interrupted. Data flow is influenced by many factors. QoS can prioritise critical traffic over non-critical traffic, for example VoIP traffic, compared to general web browsing. There are 2 components for QoS in Draitec routers, classification and scheduling. Large-scale QoS implementation uses differential code point DSCP. In the latest Draitec products and firmware, we now have the option to apply hardware acceleration to QoS. And finally, with Viga ACS3, the SD-WAN feature can be used to improve VoIP quality. Okay, that's all for me, but please stay tuned. We'll be answering questions in the live chat on the right of your screen for the next 5 minutes. For more information about Draitec products, please check out our website at www.draitec.com.au or send us an email to sales@draitec.com.au or give us a call on 02 9838 8899. Please like and subscribe below, and if you'd like a notification anytime we put up a new video, please give the bell a click too. Thanks and bye for now.